Hello everyone. In this video, we will again discuss the mesh analysis by solving one numerical. We have already discussed the basics of mesh analysis in previous video, whose link I have given in the description box so you can watch it. So let's discuss the example. Instead of taking the mathematical, I have taken this type of question. Okay, so what the question they have given: for the given network shown below, write down the mesh equation in matrix form. Okay, they have simply asked that find out the mesh equation in the matrix form. Okay, so here they have given you the values of R1, C1, R2, C2, L1, L2 and L3. Okay, so what we have to do here, we have to again follow the same step. Okay, so don't get confused. Before that, I just want to revise one thing. In the last lecture or in the video I have posted, I have find out the three values there. The first value is VR, the second value is VL, and the third value is VC. Now what is the VR? VR is actually called as voltage across resistance. V is voltage, R is resistance, and I have find out that value is I into R. Okay. So if I want to find out the voltage across resistance in this numerical, I will use formula I into R. Similarly, I have written the voltage across the inductor, and that was come out to be LP into R. Okay, I have mentioned what is the P in that video. If you have not seen that, you can go that. P is a mathematical operator or P is a d by dt. Okay, so that will be LP into I. So if I want to find out the voltage across inductor, I simply write LP into I. What is VC? VC is the voltage across capacitor. C represent capacitor. So that is equal to 1 upon Cp into I. Okay, so definitely this current is IL, this current is IC, and this current is IR. Okay, so the voltage across capacitor is calculated by 1 upon Cp into IC. So all this I have written in the ohmic value, means this is the voltage across resistance, voltage across inductor, voltage across capacitor. So for this numerical, we will be using these three formulas to formulate the equation, because we have to write only the equation in matrix form. Okay, so we will be starting with this. Okay, so what will be the first step here? Okay, so I am taking this one. The first step here is that identify the number of mesh here. So first step is that number of mesh here. So how many? You can see that this is the first mesh here. Okay, so I will be giving this as a first mesh. You can see that this is the one closed path. This will be the second closed path. You can see this will be the second closed path, and this will be the third closed path. Okay, so in this numerical we have three mesh or three closed path here. Okay, now what we do in the second step, we will assign the mesh current to each mesh. So I will assume that let I1, I2 and I3 be the mesh currents. Okay, so I will use a clockwise direction as I already told you. So this current is I1. Similarly, this current is I2 and this current is I3. So what I have done, I have considered the three mesh, and for these three mesh I have written the mesh current I1, I2 and I3. Okay, so these are the equation. The summation of IR is equal to summation of E, that we have studied. Fine. So what is the current in this R1? The current in the R1 is I1. What is the current in this I2? C1? The current here is again I1. And what is the current in L1? The current in L1 is I1 minus I2. I have told you that when we because L1 is common to first and second loop, and the current in the first loop is I1, current in the second loop is I2, so it will be definitely I1 minus I2. Okay, so I will be writing the first, the voltage across resistance is what? I into R, so it is simply I1 into R1. Okay, so value of this is simply I1 into R plus. Second is inductor. Okay, and how we write the voltage across inductor? LP into current through in that inductor IL. So it will be L1 P. Okay, P is operator. And what will be the value of current? The value of current is now here I1 minus I2. Fine. Plus. There is another element, capacitor. So how we write a capacitor? 1 by Cp. So it will be 1 upon C1P. Okay. C1 will be as it is and 1 upon Cp. And what is this IC? IC is the current through capacitor. The current through capacitor is I1. Right? And this should be equal to, but this should be equal to voltage, and voltage we have to take the account of the sign. So when you see that it is negative will become positive, so it definitely it is positive VN. Okay, so this is the first KVL equation to the mesh 1. Now what we will do, we will rearrange above equation, because we have to write in matrix form, so there are 3 unknown. Okay, so what I am taking, I1, collect the I1 terms first. So it is R1 plus, second is L1P plus 1 upon C1P. So this is the I1 term. Now consider the I2 terms. I2 terms is only one minus sign. So it is minus L1P I2. Fine. Plus. In this equation, there is no term of I3. So you substitute as 0. There is no term of that. So substitute I3 and this should be equal to VA. And write this as equation. Why we are writing in this format I1, I2, I3? So that we can easily write down this into the matrices. Okay. Now, similarly, we will write the equation for the second part, a second mesh, and correct. Okay. Now we will see the second step, and what we will do in the second step, we will repeat the step number 3. Means now in the next step, what we will do, apply KVL to loop 2. Okay, and by applying the KVL to loop 2, we can easily find out the answer. So this loop 2 is that it has 3 elements. You can see that L1, L2 and C2. First you mark the current there. Okay. So what is the current in L2? The current in L2 is I2. Okay, because this is not common to here. What is the current in C2? So C2 is the common to second and third mesh. Here current is I2, here current is I3. So this current is I2 minus I3. Right? Now what is the current in L1? Now we are considering this loop. So current is going from downward direction. So this L1 is common to second loop and first loop. So current here is I2 minus I1. Okay. So find out the voltage drop. We know L2, C2 and L1, and the equation we have mentioned here. So first is L2 into I2. Okay. So first equation is L2 into I2 plus. Okay. Here capacitor is 1 upon Cp. So it is 1 upon C2P. Okay. Plus 1 upon C2P, and current is I2 minus I3. Fine. Similarly, there is L1. So what is the value of this L1? It is LP now. So it is L1P I2 minus I1 plus L1P I2 minus I1, and this should be equal to voltage. Now if you see the second loop, in the second loop we have these two voltage. First is VB, another is VC. So follow this direction. So negative will become positive going in clockwise direction. So definitely VB is positive. But when you see the VC following the clockwise direction, positive will become negative. So answer is minus VC. So what is the total EMF here? VB minus VC. Okay. So here it is VB minus VC. Fine. So now we have written the KVL equation to second loop also. Now rearrange equation 2. Equation, okay, above equation. So I will write in terms of this I1, I2, I3 so that I can easily write in the matrix. So first you write the I1 terms. So I1 terms is here only one whose value is minus L1P I1. Fine. Write the I2 terms. So I2, there are so many I2 terms because we are writing for second mesh. L2 plus 1 upon C2P, and from this term it is L1P. Fine. After that plus write the values of I3. I3 term is this one. So there is one term capacitor term 1 upon C2P, and this should be equal to VB minus VC. So now this will my equation number 2. Right. So I have repeat the same procedure to find out the KVL equation for second loop. Now similarly I will apply for the third loop. Okay. You can see that third loop. So in third loop we have three elements here. One is resistance, inductor, capacitance. Okay. So first we mark the current. What is the current here in I2? The current here is I3. What is the current in L3? It is again I3 because it's third loop. And what is the current here in C2? Now current will come from this. So it is I3 minus I2. Okay. So now what we will do? We will write the equation for the third mesh. So I simply write the third step here. Apply KVL to mesh 3 or the loop 3. Okay. And write that. So what will be? I will use this R2 into I3. So first term is R2 into I3 plus the second term is L3. So L3P into I3. Third term is, second term is L3P into I3. What will be the third term? Third term is our capacitor. Capacitor is C2. So it is 1 upon C2P I3 minus I2. 1 upon C2P I3 minus I2. So there are three elements and this should be equal to the voltage. So now see what is the voltage. Here is only one voltage VD, and when we follow clockwise direction, positive will become negative. So definitely it is voltage fall. So that will be minus VD. Fine. Now after that what we will do? We will rearrange above equation like the I1, I2, I3 term. So there is no I1 terms here. So I will write 0 I1 plus write the I2 term. So I2 term is that, yes, minus 1 upon C2P. So this will be your I2 term plus I3 term. So there are three items, R2 plus L3P plus 1 upon C2P, and that should be equal to minus VD. So this will be the third equation. So what we have done, we have three mesh here and we have written the mesh equation for each loop. Okay. So but what they have asked in the question, write down this equation in matrices form. So now next step is very simple. Step number 4, write equation 1, 2 and 3 in matrices form. Okay. Now how many equations are there? 3. So size of matrices will be 3 by 3. Okay. So don't get confused. Like this. And you simply write that equation. Okay. Like this. So this is the first matrices equal to, because this summation of IR. So this is your Z matrix. Here we have another matrix multiplied by, it is multiplied by current matrix, that is mesh matrix, and here we have the last one, that is the voltage matrix. That will be the KVL. We know that KVL is summation of IR is equal to summation of E. Okay. So here the current is I1, here the current is I2, here the current is I3. Fine. Now you can see in equation 1, 2 and 3 voltages are V1, VA, VB minus VC and VD. So you can write here it is VA, VB minus VC and this is minus VD. So what we have written all this in a matrix. Now simply write this. So what is the first element? R1, L1. Okay. So write equation 1 in matrix form. So definitely this is a 3 by 3 matrix. Okay. So there are 3 elements in each row and each column. That's why it is 3 by 3. So like this. So see the first one. First is R1 plus L1P plus 1 upon Cp. So you can write here R1 plus L1P plus 1 upon C1P. So this is the first element with I1. Write the second one minus L1P and third one is 0. So this is minus L1P and this is 0. So this will be the first equation. You can write, I have written in the same form. Okay. Now second equation. Second equation is this one. Minus L1P is the first term. Minus L1P is the first term. Second term is L2P, L1P, L2P, L1P plus 1 upon, okay, here it is 1 upon C1P. Okay, there is a change here, 1 upon C1P. And this term is minus 1 upon C2P. Okay, you can see the third term here. It is minus 1 upon. Now we will write the third equation. Third equation is this one. So first element is 0. So 0 will come here. Second element is this one. Minus 1 upon C2P. Third element is this one, which is R2 plus L3P plus 1 upon C2P. So this complete your question, where we have written all this in a matrix form, where you can see that this and this. So these are called as the diagonal element. Okay, like this. These are called as the diagonal element. And what you observe, all diagonal elements are positive, and these are called as, remaining are called as non-diagonal element. Okay, and this matrix is called as impedance matrix. I1, I2, I3 is called as mesh current matrix. V1, V2, this VA minus VB is called as voltage matrix or the mesh voltage matrix. Okay. Now you can see I have taken 3 loops here. So this is the first, second and third. Similarly, this is first, this is second and this will be third. So matrix size is 3 into 3. Fine. And how many elements are there? 9. You can see that 3 in the first row, second row 3 and third one in. Okay. This element is called as Z11. Okay, 1 1. This element is 1 2, Z12. This element is 1 3. Okay. Similarly, this element is Z21. This element is Z22. This element is Z23. This element is called as Z31. This element is called as Z32, and this element is called as Z33. So what we observed here, I will finish in 2 minutes now. Already time is over. So here Z11, Z22, Z33 are diagonal element, all remaining are the non-diagonal. You can see that you can see here Z11 and Z21 are same. So this is a checkpoint whether you are correct or not. Okay. Z13 and Z31 both are same. Similarly, Z32 and Z23 are same. So this verifies that the question we have solved is absolutely correct. So what in that way we can solve any mesh equation. If there are 3 mesh, so size of matrix is 3 by 3. If there are 2 mesh, the size of matrices is 2 by 2. So in that way I have finished with this my question where they have asked that write down the mesh equation in the matrices form. So I have used this. Okay. So thank you very much for listening my lecture.